Hello everyone, welcome to lecture series on M3 subject. For similar videos, check in my playlist. In my today's video, I'm gonna explain to you all short trick for finding particular integral. Already I have uploaded plenty of the videos based on the short trick for finding the particular integral. Now see that particular integral can be found using 3 to 4 method, like one it is a general method, second it is a short trick, or third it is a variation of a parameter. Okay, so within that second one I'm going to finish it today itself. Short trick of a particular integral. Okay, so already I explained for trigonometric and hyperbolic function in my previous lecture. So in my today's video I'm going to explain to you all exponential function with some function of x. Okay, exponential function with some function of x. Now see that how the condition look like. Maybe this one is the fourth condition. Okay, this one is the fourth condition. Okay, so function, how it is there? If function f of x, it look like e raised to ax into v. Okay, this one is the e raised to ax. E raised to ax means exponential function, and that v we have here, which is the function of x. Okay, so this one is the function of x. V is the function of x. Okay, that means it need to have x variable present in our function. Okay, that means whenever you have f of x e raised to x into v. Okay, in such a case, how can you deal? Okay, that means f of x means we take a right hand side. Okay, in actual this one is not f of x, which is a phi of x. Okay, we consider this one is a phi of x. Okay, similar like my previous lectures, I give a notation phi of x as a right hand side for our given function. Okay, so whenever we have function phi of x which is equal to e raised to x into v is a function of x here. Okay, and we want the particular integral. So we know that particular integral can be found 1 upon f of d into phi of x. Okay, this one is a standard form for finding the particular integral. Okay, but in this case we have here two functions. One, it is an exponential function, and another is a function which contain x value. Okay, that means v is the variable that contain x value. Okay, yes. Now replace phi of x here in the our given particular integral. So how it look like? Okay, 1 upon f of d into e raised to ax into v. Okay, e raised to ax into v here. Okay, now as we have e raised to ax into v, both are the function of x. E raised to ax means the power, we have x here, and v it is also the function of x. That means both are the function of x. Okay, so take exponential function only. This one is a short trick. Okay, take exponential function only out of this 1 upon f of d. Okay, so how we write next step? E raised to ax into 1 upon f of d, e raised to x into 1 upon f of d into v. Okay, so we left here only with the value of v, so we have to work only here which use the value of v. Okay, but we don't have to keep that d as it is. Okay, as we have exponential function as e raised to ax, so instead of a d we replace a in our previous example whenever only it is the exponential function. But as we have two function which is in the multiple, so we add a here. Okay, we add a d plus a into v. Okay, this one is a required particular integral. This one is a required particular integral that we are going to apply for our example. Okay, now see that this formula or particular integral for two functions, which is more important for solving the example. You won't get the question like fill in the blanks or directly the formula based question. You won't get such a question in your SPPU question paper. So you will get the example, and based on this example you have to apply this particular integral here. Okay, so let's go for some of the example based on this formula. So this concept will be very much clear for you all. Okay, So before I start my example, I have some one or two result, okay, that you all need to remember. I knew it that most of you all have learned binomial theorem, okay. That means all of you learned binomial theorem in your previous class, like 11th standard, 12th standard. What actually we learn in a binomial theorem? The binomial theorem says that how to find x plus y to the power n, x minus y to the power n, and so on, okay. That means a plus b raised to n, a minus b raised to n. That is the expansion we learn in our binomial theorem, okay. So actually we don't need this one, but that you need to know this is coming from binomial theorem, okay. So we need only the two standard form for finding the particular integral. One, it is here 1 plus x raised to minus 1, okay. And another standard form we need here 1 minus x raised to minus 1. This one is another standard form, okay. So we want the expansion. So a plus b raised to minus 1, okay. And now see that if you are going to apply 1 plus 1 upon 1 by x, okay. That means 1 plus x raised to minus 1. How can we write 1 plus x, like 1 upon first term into common difference? It's similar like a geometric series, okay. How the geometric series looks like, first term upon 1 minus common difference, okay. This is the sum of a nth term of a geometric series. So you can expand using geometric progression, or directly I'll tell you the short trick how can you write, okay. Yes, now see that it is a plus here, minus here, okay. So what you do, we take plus minus in this way, okay. So 1 plus x, it is plus here, then take minus, okay. Alternate signature we want. 1 minus x plus x square minus x cube plus x raised to 4 minus x raised to 5 plus so on, okay. This is the expansion, okay. This one is the expansion for 1 plus x raised to minus 1. As it is a plus and minus, that's why we are taking alternate sign, plus minus like this, okay. But as we have minus now, so minus always gives us the positive. So remember the short trick, we write 1 plus x square plus x cube plus x raised to 4 plus so on, okay. Now see that minus we are going to write here as a positive, okay. So we need to remember these two forms that are useful for our subsequent examples, okay. Yes, let's go for one of the example that coming from your university question paper, okay. Yes, these are the important questions that I'm taking here, which ask in SPPU question paper, okay. SPPU, okay. These are the previous year questions from SPPU question paper, okay. So we write d square y by dx square, okay. D square y by dx square minus 4 times dy by dx plus 3, which is equal to x cube into e raised to 2x, okay. This one is an important question asked in your previous year question paper, okay. You need to be very much careful about such example. These are the very easy example, just don't have to make any mistakes, okay. Yes, okay. Let's get to solve this example, okay. Now see that for finding the complementary function, it is quite easier, okay. I'm gonna leave this complementary function to you all, okay. Find out the complementary function and tell me what is the value it is coming, okay. For complementary function, what we do, we convert first auxiliary equation, okay, using our given differential equation. So what is the auxiliary equation? D square, that means it is d square minus 4d plus 3, which is equal to 0. Find out the root. If the roots are repeated and distinct, okay, then use the formulas, okay, like c1 e to the power m1x, c2 e to the power m2x. Such a way you have to apply the formulas, okay. Yes, so complementary function, it is easier, that I'm leaving you all to find out this one, as we are learning only the short trick for a particular integral. So let's focus only on the particular integral, okay. Yes, we want the particular integral for this function, okay. So as we have here f of d, which present here, this one is a phi of x, okay. Let me write first of all f of d, okay. F of d here d square minus 4d plus 3, okay. D square minus 4d plus 3 as our f of d, okay. And phi of x means this one is a phi of x e raised to 2x into x cube, okay. Now you can see that it is completely applicable to our previous result, e raised to ax into v, okay. Now you can see that we have learned the standard form here, e raised to x into v, okay, that we have to apply here. That particular integral, e raised to x goes to be the out, and 1 upon d plus a into v it is here, okay. Now be very carefully see the solution now, how I'm going to solve this one, okay, because we don't have to replace all the values. We have to replace some particular value for finding the particular integral, okay. Yes, okay, let me write particular integral now. Okay, particular integral we have here 1 upon f of d, 1 upon f of d. So 1 upon f of d can be written as d plus a, as we have here particular integral e raised to ax into 1 upon f of d plus a into v, okay, 1 upon f of d plus a into v, and e raised to ax outside here, okay. This one is our required particular integral, okay, as I written here, e raised to x 1 upon d plus a into v, okay. Yes, this one is. Now we have to replace the values over here, okay, we have to replace the values over here, okay. As we know that if you're going to find out the roots, okay, if you're going to find out the root for f of d we have here, d square minus 4d plus 3, d square minus 4d plus 3, okay. Find out the common factor for these two ones, okay. So d minus a and d plus a, okay, such a factors are coming, okay. Let me write this one, d square minus 4d plus 3. So we want the two number, their multiplication is 3 and their addition is minus 4d, okay. So which are these two numbers? So if you are going to write 3 minus 3 into minus 1, okay, minus 3 into minus 1, their multiplication goes to plus 3 and their addition minus 3 into plus. So expand this one, d square, okay, we want the two number, their multiplication it is positive 3 and their addition is a minus 4d, okay. So minus 3 into minus 1, minus minus it gives the plus 3, and there minus 3d and minus d which is a minus 4d, okay. So how I'm going to write it here, now see here, d square keep as it is, okay, minus 4d can be written as minus 3d minus d, okay, minus 3d minus d minus 4d plus 3 here, okay. So this one is the expansion for our term. Take d common from here, d minus 3, okay, take again what we take minus 1 common, d minus 3, okay. Yes, we get the d minus 1 and next root d minus 3 here, okay. These are the two roots over here, okay. So this one is actually f of d, okay. So if we want f of d plus a, okay. Now see carefully how I am going to write the solution. So I have here f of d as a d minus 1 and d minus 1 and d minus 3. I want f of d plus a. So how I'm going to write f of d plus a? F of d plus a which is a d plus a minus 1 and d plus a minus 3, okay. So how I have written, now see that d replaced by d plus a, d as it is here, it is same is here, okay. So I replace d as a d plus a, so replace d as a d plus a, again d as a d plus a, okay. Yes, so as we have e raised to ax, that means the value for a which is a 2, okay, value for a which is a 2 here. So replace f of d plus 2 is equal to d plus 2 minus 1 and a d plus 2 minus 3, okay. So what we will get, the 2 minus 1 1, okay. So d plus 1 and a d plus 2 minus 3 which is minus 1, d minus 1, okay. So f of d plus 2 can be written as d plus 1 and d minus 1, okay. In actual we write a d square minus 1 square, okay. So f of d plus 2 I written this way, d square minus 1 square, okay. In actual we have d square minus 1. So how why I need to reduce this term here, I will explain to you all again, okay. Yes, so f of d plus a, replace instead of it here, okay. So I'm going to write particular integral as e raised to ax, that means e raised to 2x, okay, e raised to 2x as it is, okay. 1 upon f of d plus a, that means f of d plus 2 which is a d square minus 1, okay, d square minus 1 and into multiplied by phi it is here, okay. So how it written, it is a v here, okay. So v it is the function of x and the function of x we have here x cube, this is the value for v, okay, this is the value for v, e raised to ax it is here. So keep x cube as it is, okay. x cube keep as it is. Yes, now what we are going to do here, as we learn two results, okay, these two results, okay, one of that result we have to apply here, okay. So how we are going to write that result? See here, e raised to 2x keep as it is, d square minus 1, take this part to the numerator, as differentiation cannot work at denominator. It work, but it is more complicated, but to avoid such a situation we take that denominator to the numerator. So we write d square minus 1 to the power minus 1, okay. So what I have done, I written this denominator term, I taken this denominator term to the numerator, okay. So when denominator goes to the numerator, it gives the power as a negative 1, okay, multiplied by x cube. This one is our required term, okay. Yes, we have to reduce, or we have to take that d square out from this term, then we will get the required particular integral, okay. Yes, particular integral e raised to 2x, okay, particular integral we write e raised to 2x as it is, okay. Now see that d square minus 1 to the power minus 1, okay. Now what we have here, what we have, now see it carefully, d square minus 1, but as we have 1 plus x 1 minus x, that means we have to reduce the term 1 minus d or 1 plus d, okay. So take negative sign common from here, so at the denominator if you took negative common from here, we write 1 minus d square and a negative outside here, okay. So negative 1 minus d square to the power minus 1 into x cube. I hope you all have understood how I have written this term, okay. This one is a negative I taken out from here, okay. I will explain this term how I have written, okay. See that d square minus 1 now, take negative common from here, so 1 minus d square left here, okay. That negative term I taken here, so 1 minus d square, it is only remain in this bracket, so 1 minus d square, take it to the numerator, so 1 minus d square to the power minus 1, it goes here, okay. Yes, so why I had taken, because we have 1 minus x or 1 plus x in the form of the terms, okay. Yes, so take negative 2 out here, so we write e raised to minus 2x, okay, negative of e raised to minus 2x, okay, and 1 minus d square to the power minus 1. Now see that we have 1 minus x to the power minus 1. Instead of x, replace d square. Instead of x, what we have here, d square, okay. D square, we are going to replace d square instead of x, 1 minus x to the power minus 1. That means 1 plus d square plus d raised to 4, x square it is there, means d square to the power 2 plus d square to the power 3, okay, d square to the power 4, okay. In this format we are going to replace it here, okay. So let me solve this term only, okay. I'm going to explain how can we solve this term here. And now I written here particular integral, okay, that I want to solve this term only, okay, because it is 1 minus d square we have to remove in order to get the required particular integral, okay. So 1 minus d square to the power minus 1, that means 1 minus x to the power minus 1, 1 minus x to the power minus 1. The expansion it is here, both are the term negative, so make it the positive, 1 plus x square plus x cube plus x raised to 4 plus so on, okay. This is the actual 1 minus x to the power minus 1 expansion it is here, okay. So we want 1 minus d square to the power minus 1, so 1 minus d square to the power minus 1, okay. Expand this term with the power negative 1, okay. So how we are going to write? So now see that instead of x we have d square, replace only instead of x d square, okay. So instead of x, which is a d square, okay, instead of x, which is a d square, that means power to remain same, plus instead of x, which is a d square, power to remain same here, okay. Power 3 it is coming, okay. Instead of x, which is a d square, power 4 remains same, plus so on, okay. Yes, so 1 plus d square plus d raised to 4 plus 2 3s are 6, power to the power means we take their multiplication, okay. 6 plus d raised to 2 4s are 8 plus so on, okay. This one is our required expansion. So replace this value 1 minus d square to the power minus 1 instead here, okay, instead of 1 minus d to the power minus 1. So we are going to write particular integral as minus e raised to 2x 1 minus d square to the power minus 1. Okay, this one is the term 1 plus d square plus d raised to 4 plus d raised to 6 plus d raised to 8 plus so on. Okay, in actual means it is double differentiation. What is the meaning of this entire term? 1 plus twice differentiation here. Okay, capital D means d by dx. Okay, d square means d square by dx square. Okay, it is 6 times differentiation, 4 times 8 times differentiation. Okay, yes, so all it is applicable for x cube only. All it is applicable for x cube, because d by dx of x cube it is there na. So that means this is a term which is outside already, so we have to take the differentiation here with respect to this term. Okay, so keep e raised to minus 2x as it is. Okay, take x cube under bracket. Okay, it is x cube remaining here. Okay, take x cube under bracket here. X cube into 1 x cube plus d square into x cube plus d raised to 4 into x cube plus d raised to 6 into x cube plus so on. Okay, this term goes to the at the infinity. Okay, yes, but at some certain point we know that the differentiation of a x cube, it goes to the 0. That means we don't have to worry for the infinity term. Okay, so e raised to minus 2x, it out here, x cube remains same. D square x cube means 2 times the differentiation of x cube. Okay, 2 times. Now see that we have here d square x cube, that means d square by dx square into x cube. Okay, yes, this is the actual meaning. Okay, that means we have to differentiate it 2 times. Okay, we have to differentiate given function 2 times. Okay, first time differentiate it, we left here with the d by dx, x cube having differentiation 2x square. Okay, yes, again one time differentiate it, we get the 4x. Okay, that means 2 times differentiation, it gives a 4x value. Okay, again 4 times differentiation, this one is only 2 times differentiation, so 3 times differentiation, d cube by x by d cube by dx cube, we are going to write d cube by dx cube, that means differentiation of 4x, which gives us the 4. Okay, and d raised to 4 by dx raised to 4, which is a 0. That means 4th differentiation gives our function 0. That means 5th differentiation, it also goes to 0. Remaining all the differentiation, it gives us the value 0. Okay, so we left here with the value of, so here is the differentiation x cube, first differentiation 3x square, second differentiation 6x, next differentiation 6, later on all the zeros. Okay, so this one is not 4x, this one is actually 6x. Okay, yes, we left here with the term e raised to minus 2x into x cube plus 6x. Okay, this one is our required particular integral. Okay, this one is our required particular integral. So if you want general solution, write down complementary function plus particular integral. Okay, so about to find out complementary function, I already explained in my previous lecture for complementary function. Now particular integral, I got it here. Okay, I hope you all have understood my entire solution. Okay, which is a short trick for finding the particular integral. You will get such a question for your university SPPU exam for 4 marks. So now see that how easy questions are these. Okay, just these are little bit calculation based the question, but nothing it is difficult, everything it is easy. But even after, if you found anything difficult, let me know in my comment section. I will come up with the similar videos. Okay, so this one is our required solution for particular integral. Okay, I hope you all have understood my complete solution. Okay, that's it for my today's video. So thank you everyone, thank you for my today's lecture.